In this lecture, I will give the demonstration for pointers. So what I have shown you in the whiteboard lecture, let us look at the demonstration for it. So for demonstration, I will go to online GDB. So here in Google, search for online GDB. See, various compilers are available. So let us select C++. In this you can write both C and C++ programs. Yeah. So let us remove this one. Pointer. Like I have shown you, a variable is declared here on whiteboard. I have shown this. The same thing I will do. This variable a is of type integer, and if you want to print a value, so I can say cout a, and the value of a will be printed. So this is the integer variable having value 10. Yeah, it has printed the value 10. So this is a variable a. It consumes 4 bytes in the memory. Now to this variable we can also assign a pointer. So I have taken a pointer star p. So integer a assigned 10 and star p is a pointer. So this statement is a declaration of a pointer. Then later on in the next line I can say assign address of a. Ampersand a means address of a. Address of a is stored in p, that is pointer. So when we are assigning the address, we don't have to write star. We have to write star or asterisk only at the time of declaration, and the next time we have to do is at the time of dereferencing. So star should be used at declaration and dereferencing time. Here I am storing the address of a in variable p. So p is a pointer type variable. So just p you have to write. This is the syntax. Syntax means if you write like this, compiler will understand, right? Now don't say that, sir, if I write star, what will happen? Compiler will not understand it, right? If you write star again here, compiler will not understand. You may get some errors. So you can try out. If you are getting some ideas, you can experiment them by yourself. So I have a pointer. Now let us print the value of a with the help of pointer p. So now p is having address of a. So let us dereference it. So for that I will use printf. Okay. So just I want to show you that I can use C code as well as C++ code, right? stdio.h. Now after printing value of a, here I will say printf. This is using pointer. I will print %d, the value of a. So actually I should give star p here. Yes, star p. Dereferencing. Just p means a pointer which is having address. Star p means it will go to that address and take the value. So that value will be printed. So let us run the program and see. Yes, 10. Then after that the next line is using pointer 10. So it is coming in the same line. If I write NL here, then it will come in next line. Okay. So if I write NL after a, it will come in next line. So it will print the value 10. Yes, using pointer 10. Now if I don't write star here, if I write just star, just p, then what happens? So let us see what happens. Yeah, it is printing, but it is not printing the data. It is printing some address because p is a pointer. Pointer is having some address. It is giving some warning because we have used %d and printing a integer type pointer. So you can ignore this warning. So it is printing address, right? So let us do one thing. Along with this, I will say %d for ampersand a also. See, first one is a pointer, second one is an address of a. Both should be same because both are the address. A, ampersand a is the address of a and p is pointing to that a. So both should be same. So let us see the output. Yes, both are same. It is showing the same number. So it is showing the address of a. So if you write star, then only you get the data. So remember, for a declaration use star, for dereferencing use star, alright? We don't need to see the addresses, okay? Then for at initialization time, don't use a star. As well as for pointer arithmetic, don't use a star. So this is about a pointer to some variable a, alright? Now the next thing is, I will show you pointer to an array. I will remove all these things. We can have a pointer to an array. I will create an array of size 5 and I will initialize it with the values 2, 4, 6, 8 and 10. So 5 values are initialized. Then I will take a pointer p and also I will initialize. Okay, no, I will initialize it in the next line. So P assign A. Where is ampersand? The syntax is you don't have to give ampersand when you are giving array name to the pointer. So because name of an array A itself is the starting address of this array, right? So P is a pointer, so it can store the address. If you want to use ampersand, then you should say A of 0 means this is 2, A of 0 is 2, and its address, then you should write ampersand. So you have two options. Either you write ampersand A of 0 or just write A. Okay, just write A. Don't write ampersand A, it will be wrong. It is invalid syntax. Compiler may or may not give any warning for you, so you may not get proper results. So don't use ampersand A when you are initializing a pointer with an array, right? So just take A. Then, can I access all these elements using pointer? Yes, you can access all these elements using pointer to an array. So I will print all the elements using a for loop for I assign 0, I is less than 5, I plus plus. Then using cout, I will print all the values A of I. So let us see, and also I will give adl so that they appear in new line. So let us see the output. Yeah, here we got the values 2, 4, 6, 8, 10. I have printed all the values using A. Now how to access them using pointer? Just say P of A, P of I. So in place of array name A, can I use a pointer? Yes, you can use it. It will act just like the name of an array. So in case of arrays, pointer acts as name of an array. Now I'm executing it. Yes, using P also, it is printing all the values. So P is a pointer which can act as a name of an array. Yes, this is interesting. So pointer to an array. Where the array is created, it is created inside the stack. Remember, once again I am telling you, whenever you declare anything in your program, it is going to be created inside the stack frame for that function. So it will be created inside the stack frame of main function. Now next thing, let us create an array in heap. So using a pointer, you can create an array in heap. So I will remove this, and this is also gone. Now we have a pointer. Now to this pointer, we can assign a array created in heap. So for that, I should use malloc function and 5 into size of int. This is what I have explained on whiteboard. So malloc function, for malloc function I should include stdlib.h also. So malloc function will allocate the memory for 5 integers. So it's an array of integers and it is assigned to a pointer p. So you can see that only p is inside the stack, but this array of 5 integers is in the heap. Now I will initialize all the values. I have only 5 values, so I will initialize them. First value is 10 and p of 1 15. Okay, then p of 2 is 14. I will just randomly assign some values. P of 3 is 21 and p of 4 is 31. Then here I am printing, so it's an array. When we have allocated 5 integer means it's an array. So I am assigning all 5 elements, then I am printing them. So I will get all these values printed, and this array is created in heap. So let us run and check. Here you can see that all these values are printed here. So this is an array inside heap. Now I will show you a C++ method of doing it. So instead of using malloc, we can just say new int of size 5. This is very simple in C++. Now this 5 what? Integers. So it's an array, 5 integers, right? And then it will automatically convert into integer pointer and assign it to p. So it is acting just like malloc function, but the syntax is simple in C++. Alright. See, I am using mixed code of C and C++. So you can write down the C language code inside C++ programs also. And once again, I am telling you, if you know C++, so you already know C language also. Alright. So let us run this and check. So using C++ syntax also, I have created an array and initialize all the elements, then I am printing them. So this is C++ syntax. Now the next thing about dynamic allocation. See, here we have dynamically created the memory for an array in heap. So by using new, we made a request for memory in heap. So when we have finished using it, we should also delete that memory, because we are creating an array here. So we should use square brackets, opening and closing square brackets. These are, I will give a space so that you can see it. Delete, opening and closing square bracket, and then P. If it is any other type of variable, then you can just write that variable name. If it is an array, then you must write down this subscript, right? So remember one thing, whenever you are dynamically allocating memory, you must release the memory by the when you have finished using it. And if you are using C language, then you have to say free P, free. Free is used in C language, delete is used in C++, right? So this is for deallocating the memory that is allocated in heap. So heap memory should be deallocated. And one more thing, as the program is very small, the moment you run, it will execute few steps and finish. So in such programs, if you are skipping this, it's not a big problem, right? If you are skipping the deletion part, then it's not a big problem. So mostly in students size programs, like the programs that we'll be doing in this course, are small programs. They are not big projects. In the projects, this is very crucial thing. You must handle it very carefully. When memory is not required, you must delete the memory, right? For these small practice programs, you can skip them, right? Even when you do data structures, then there also it is good if you are deleting it. And if the program is very short, then if you skip, then it's not a problem, because once the program ends, the heap memory will be automatically deleted, right? It will not be there once the program ends. Now the next important thing about a pointer. See, first of all, I will write down some code here, then I will explain you what is that. So I have removed that code. See, first I have a pointer of type integer p1, and then I will take a pointer of type character, and also I will take a pointer of type float, then also double p4, okay, there's a pointer, and also I will take one pointer of type structure. I have defined a structure here, and then I will take a pointer of type structure also, struct rectangle star p5. So I have 5 pointers. Now I will print size of p1, that is pointer p1, size of the pointer. Then I will do the same for all the pointers. So I will copy this. Now I'm printing the size of all the pointers. Now the interesting thing is, I have different type of pointers and I am printing their sizes. So integer pointer should take 4 bytes, right? Character pointer should take 1 byte, right? Because character is 1. Float pointer should take 4 bytes, right? Because float takes 4. Let us check. Oh, it is showing 8888. So every pointer size is 8 byte. I was thinking 4 byte, 1 byte and 4 byte. No. Yeah, this is the interesting thing. Whatever the data type of pointer is, pointer takes same amount of memory. Every pointer takes same amount of memory. You can see that all these pointers are taking 8 bytes, right? So whatever the type of pointer may be. In the latest compilers, the pointers are taking 8 bytes. Earlier, they used to take 4 bytes, that was equal to integer size. But in latest compilers, they are taking 8 bytes in 64-bit machines. So whatever the type of pointer is, it is independent. Size of a pointer is independent of its data type. That's it. This is the important thing and the interesting thing about pointer. So that's all in this video. I suggest you practice all these things so that you get used to with these things. Don't simply watch the lectures. Try to practice everything, right? So this will help you further in the course. So that's all.